Greetings, Doctor. I'm Suresh, son of Rajarajan, and my matrix number is 301984. My part is Introduction and Literature Review. Introduction. The proliferation of electronic gadgets has transformed our daily lives, but it has also led to a significant increase in e-waste. This waste contains harmful substances like lead and cadmium, posing serious environmental and health risks, particularly in areas with informal recycling practices. Effective e-waste management is crucial to prevent contamination of soil, water, and air. Sustainable solutions include implementing strict regulations, promoting reuse and recycling, and educating the public on proper disposal methods. By taking these steps, we can reduce the negative impact of e-waste and manage our electronic footprint responsibly. Literature Review. The rapid advancement and turnover of electronic gadgets have led to a surge in e-waste, which doubled from 53.6 million metric tons in 2019 and is projected to reach over 74 million metric tons by 2030. E-waste contains hazardous substances like lead and mercury, posing serious health and environmental risks, particularly in developing countries with inadequate recycling practices. Effective e-waste management requires strict policies, improved recycling technologies, and public awareness. The EU's legislation on extended producer responsibility serves as a model. Future efforts should focus on sustainable management, improved recycling technologies, and fostering a circular economy to mitigate e-waste harmful impacts. Thank you.
Assalamualaikum and hi. Today I want to talk about e-waste landscape in Malaysia. In the digital era, the increased use of electronic devices has led to a rise in e-waste, which contain hazardous toxic materials. E-waste includes computers, smartphones, and households appliances. Improper management can pollute the environment and endanger human health. In Malaysia, e-waste management is still developing with efforts to improve collection and recycling. The environmental quality regulation govern e-waste management. Challenges include technology, cost awareness, and regulatory compliance. Solutions include extended producer responsibility, take-back programs, advanced recycling technologies, and public awareness campaign. Thank you. Of e-waste. In 2020, Malaysia generated approximately 364,000 metric tons of e-waste, with an annual increase driven by urbanization and technological advancements. Improper disposal of e-waste leads to soil and water pollution from heavy metals and hazardous chemicals, causing serious health issues such as neurological damage and respiratory problems. Malaysia has implemented the Environmental Quality Regulations 2005 to classify e-waste as scheduled waste and is developing a national strategic plan for e-waste management. Factors such as low public awareness, inadequate infrastructure, weak enforcement of regulation, and cultural practice that do not prioritize waste management contribute to improper e-waste disposal issue in Malaysia.
Good day, Doctor. I am Theodian Wei, and my metric number is 301759. Based on the Malaysia Department of Environment (DOE), the example of e-waste in Malaysia could be separated as two major sources, which are industrial and household sources. Currently, they only define these six items encompassing mobile phone, computer, television, air conditioner, refrigerator, and washing machine as e-waste in Malaysia under the code SW110 First Schedule Environmental Quality Schedule Waste Regulation 2005. Next, what is the impact of improper disposal of e-waste? The inadequate e-waste disposal practices would cause pollution of this aspect, such as air, soil, water, and further impacting human health issues and the ecosystem balance. E-waste could release toxic substances inside of it into the atmosphere and affect the air quality when e-waste is disposed through open burning and an acid bath method. Furthermore, inhaling these hazardous substances could lead to breathing problems, cardiovascular disease, and even evolve to cancer or other health problems in the surrounding community. Besides that, dumping the e-waste in the landfill illegally, these toxic substances will disrupt the soil condition like temperature, soil type, pH level, and soil composition and may harm the plant around it, which are not suitable for agriculture and other purposes anymore, due to the hazardous substances will remain in the soil for a long term. After wildlife or animal consuming it, also might cause health issue. The contamination substances from soil have the potential to leak into groundwater that eventually flow to the river and ocean, which will contributing to water pollution and further becoming a threat to the aquamarine life, which affect the imbalance of the ecosystem. It is difficult to maintain the cleanliness of water source and clean water for human consumption. Lastly, the informal disposal e-waste worker will face a higher risk of serious health issues because of the long-term effect of exposure to these toxic substances. For example, the lead would affect the development of brain and rubber. Cadmium would weaken human bone strength by reducing the calcium from bone. The copper will damage our lung and kidney function inside our body. Now we have understand the impact of improper disposal of e-waste. So how to reduce it? First, increase the public awareness and education toward e-waste. By increasing the public awareness toward e-waste, it enables the public to understand e-waste and good practices for disposing of the e-waste. My e-waste or my DOE application facilitated the public to have a better understanding of environmental issues in Malaysia and identify the former collection center of e-waste. Second, enforcement of the e-waste legislation. The enforcement of the e-waste legislation will advocate the household having good e-waste disposal practices where it prohibit the informal and illegal disposal recycle with warning and penalty. Third, introducing extended producer responsibility EPR system. It applies in many developed countries, including the Europe, China, Hong Kong, Japan, and South Korea. It emphasizes that manufacturers and importers share the responsibility of the product until its end of the life, like paying the recycling fee to collect and dispose the product in an environmentally sound manner.
Next is the case study and real-life example of the e-waste in Malaysia. The first case study is the e-waste management in the Malaysia Communication and Multimedia Commission. The NCMC is an organization that has played a crucial role in managing the communication and the multimedia sector in Malaysia. They have also cooperation with the telecommunication company to ensure compliance with the US regulation. For example, they has implement the safe disposal and recycling of the outdated electronic equipment such as mobile phones, model, and computers. And the second case study and example in Malaysia is Sabah US Awareness and Collocation Program. Due to the state geographical diversity and rural population that has faced some challenges in the waste management, and to solve this problem, the state government has delivered the vehicle that has specially equipped driver remove the village and town to collect the e-waste. This solution has made the residents can easily dispose of their e-waste. And then the next case study is Petaling Jaya digital campaign for the e-waste recycling. The City Council of the Petaling Jaya has organized a comprehensive digital campaign to encourage the residents to recycle for the e-waste. They has used the social media, to spread the online awareness campaign. For example, they has used the platform like Facebook, Instagram, and Twitter to run the education campaign about the hazard of the US. The city council also collaborates collaboration with the local news websites and community blogs to help spread the awareness about the US. The aim is to let more the listeners know about the hazard of US and benefit of the recycling. And the last case study is the US recycling facility in the Penang. The greenhouse of Penang have established the numerous US collection points in the residential areas like school and public facility. There has also to increase the education and awareness campaign of US among the school. For example, there has organized a campaign like US is my responsibility in the school to increase the awareness and fostering a broader culture of environmental responsibility. That's all my part. Thank you.
Recycling e-waste is a challenging process because of the complex structure of e-waste containing a diverse range of material. Several technologies have been developed to recycle e-waste, such as pyrometallurgy, hydrometallurgy, biometallurgy, and a combination of those. However, there are challenges associated with each method, including the requirement of certain pre-treatment. This chapter provides a critical review of different e-waste recycling technology, including various pre-treatment steps, with a particular focus on novel recycling technologies. Furthermore, it provides a comparative analysis with those of conventional technology, including recent development and challenge. A discussion is also made in this chapter on different commercial and new recycling technologies. Most importantly, viewpoints are given on the future investment of e-waste recycling technologies. This chapter shows that a great deal of commitment and contribution by researchers has gradually led toward the development of numerous sustainable e-waste recycling technologies globally. Based on the literature, it can be further conclude the future e-waste recycling technology would be more eco-friendly, cost-effective, and efficient by implementing an integrated recycling process accompanied by various recycling technologies. Prospective avenue for managing e-waste underscore the necessity of inventive and comprehensive method to tackle the escalating ecological and health hazard associated with electronic trash. The creation of more effective and environmentally friendly recycling system that can securely extract valuable components from e-waste while reducing harmful emission and residues is one promising direction. Research on biological technique is gaining steam as a sustainable substitute for conventional chemical and mechanical process, such as the employment microfiber for bioremediation, enhancing the lifespan, separability, and recyclability of electrical equipment through design is also essential. In order to do this, stronger law governing the use of hazardous material must be put into place, and circular economy idea in which items are made to be reused, refurbished, and recycled must be promoted. For the conclusion is discard, electric and electronic equipment or e-waste present serious risks to human health and the environment everywhere. As a result of fast progress of technology and the ongoing replacement of gadgets and increasing volume of electronic trash is produced. Hazardous material like lead, mercury, and cadmium are included in this trash. This material can pollute soil and water, endangering ecosystem as well as human health. To reduce this risk, proper recycling and disposal of trash are crucial, but many nations lack the infrastructure and law needed to handle e-waste responsibility. A complex strategy combining producer, consumer, and government is needed to address the e-waste issue. Sustainable design must be given top priority by manufacturer in order to produce goods that are simpler to update, recycle, and repair. Customer must be made aware of the value of disposing of waste responsibly and the assistance of recycling initiative. In the meanwhile, lawmakers must implement and maintaining strict law to guarantee the responsible and safe handling of e-waste, penalty for inappropriate disposal, and incentive for recycling may also be quite effective in lowering the amount of e-waste produced.